We are starting chapter 6. Chapter 6 is going to start all about functions and what we're able to do with functions. We've already learned about functions all the way back in chapter 2. Functions are input-output machines. You plug something into the function, you get something out. The biggest thing you have to remember about a function, though, is that an input can only create one output. I can't plug a number into a function and then that function spit two different outputs out. A function cannot do that. To be a function, when I plug a number in, it can only possibly spit one number out. Okay, that's very important to remember about functions. So the first section is just going to have us perform operations with functions. So we're going to be adding functions together. We're going to be subtracting functions, multiplying functions, and dividing functions. So it's going to feel hopefully extremely simple in the sense that it's going to be combining like terms. It's going to be FOILing. It's going to be factoring. So it's all skills that we've already learned. We're just putting it together now. All right, so here we go. Let's just get used to the notation they're going to use, how they're going to ask you to add two functions together or subtract them. So if they're going to ask you to add two functions, they're going to ask you to take f plus g of x. So in reality, what they're asking you to do is take the f of x function, which is usually defined by some mathematical expression like 3x plus 2, and they're going to ask you to add it with the g of x function, which again will be defined by some mathematical expression. So you'll just be taking a mathematical expression and adding it with a mathematical expression, and then combine like terms. Very simple. All right, subtracting. If they want you to subtract functions, they're going to ask you to find f minus g of x. So that is take the f of x function and subtract the g of x function from it. Now, guys, just be careful because the order in which you add will never matter. So if you did f plus g or g plus f, your answer wouldn't change. But subtraction, the order matters. So pay attention to which function you're subtracting from which function. All right? If they ask you to multiply, they're going to ask you to find f times g of x, which is going to be take the f of x function and times it with the g of x function. So that'll probably feel like a FOIL problem where you're just distributing over and over and again. All right, and then last, if they want you to divide the functions, they want you to take f divided by g of x. So you're going to take the f of x function and you're going to divide it by the g of x function. Now, luckily, we're going to use a shortcut to that division. Instead of us having to go through the long division or the synthetic division, there's another shortcut we can take, and that will just involve factoring. All right, so here we go. So if you ask me, these problems are only as difficult as the functions they give you. If they give you these big giant functions that are defined by these huge mathematical expressions, then yeah, multiplying them out might take long. But otherwise, it should just be simple algebra. All right, let's look at the first example. All right, so in example 1, they have given you the f of x function. This is function f. When you plug an x into it, this is what will happen to that x value, right? This is the mathematical expression that defines the f of x function. All right, it says g of x is equal to x plus 1. So this is function g. When you plug an x value into it, this is what will happen. This is the expression that defines the g of x function. So guys, let's say in part A, they ask you to find f plus g of x. That literally is asking you, I prefer to look at it like this. They're asking us to take f of x and add it with g of x. So we have to add these two functions together to create one new function. So f of x, guys, was this. It was 3x squared minus 2x minus 5. Now they want us to add that with the g of x function. G of x was this. It was x plus 1. So you're literally just going to combine like terms to add these two functions together. So really simple. So if we combine like terms, 3x squared, no other x squared, stays the same. Minus 2x's plus 1x is going to be minus 1x, minus x. And then negative 5 plus 1 is going to be minus 4. And that is your new function that you get by adding the f and g function together. So nice and easy. right? So this has to feel good coming off of that graphing and all that. Just nice, simple algebra again. All right, let's look at part B. Let's say in part B, they ask you to find f minus g of x. Now, don't get overconfident like, oh my God, we're just adding and subtracting. We do have to be careful. There's are certain rules we have to follow. All right, so if they ask us to do f minus g of x, they want me to take f of x, and they want me to minus the g of x function from him. So order matters. Make sure you put f first, and you subtract g from it. All right, so f of x again, guys, that was this expression. That was 3x squared minus 2x minus 5. Now we have to subtract. But here's the thing about subtraction, guys, is I have to make sure that I subtract the entire g of x function from f of x. So I can't just put minus the next expression. I have to make sure that I subtract all of that next function. So you have to keep the next function in parentheses to show that you'll be subtracting all of it. So now I'm going to subtract all of g, which was x plus 1. So there's going to be a negative sign that you're going to have to distribute along with this subtraction. Because if I just put minus x plus 1 with no parentheses, then technically all I'm minusing is the first term of g of x. But I want to make sure that I subtract all of g of x. So now we have to distribute our negative, and then we can combine like terms. So let's just do this. That's going to be minus x, and then minus 1. And now we can go ahead and combine like terms. All right, so 3x squared and no other x squared will stay 3x squared. Minus 2x and minus 1 more x is now negative 3x's. All right, and then negative 5 minus 1 more is now going to be minus 6. And there is your new function that you get when you subtract g from f. And you're done. So it's nice and easy. So again, I just can't stress enough that with the subtraction, you must use parentheses. You have to put that function that you are subtracting in parentheses. Otherwise, you will not get it correct. Okay? How do you guys feel? Nice and easy so far, hopefully. Guys, thumbs up at home. Yes? Awesome. All right, here we go. So in part C, let's say they asked you now to find f times g of x. Well, in this case, they're literally asking you to take the f of x function and times it with the g of x function. We have to multiply them together. Okay, so f of x was this expression. So I'm going to take all of it, 3x squared minus 2x minus 5, and I'm going to multiply it with all of g of x, which was x plus 1. So guys, multiplying. If it was just straight up multiply, then we would just multiply. 2 times 3 is 6, 6 times 4 is 24. But when you have all of this addition and subtraction to multiply over, you have to distribute. The only way to multiply over all of this addition and subtraction is to distribute. So it's basically a big giant FOIL. And let me just say, guys, the order in which we multiply doesn't matter. So if you wanted to put x plus 1 in front and do technically g of x times f of x, you could totally do that if that looked more comfortable for you. The order in which you multiply will never matter. All right, so all we're going to do is take the first term in that first function, and we're going to distribute it to the second function. So we're going to take 3x squared times x. That's 3x to the third, right? Because when we multiply, we add our exponents. All right, then I'm going to take 3x squared and I'm going to times them with the next term in the second function, which is plus 1. So 3x squared times 1 is positive 3x squared. Okay, since you have taken this term and multiplied him with everything in that next function, you're done. Now we take the next term and distribute that to everything in the next parenthesis. So now we're going to do negative 2x. And if this helps you keep you organized, I saw a teacher do this and I kind of really liked it, so I'm going to do it too. Negative 2x times x. That's negative 2x squared, right? So I'm going to start listing that under the like term. It's a negative 2x squared because sometimes when you have a lot of distributing, you can end up with like a really long list of terms. And then when you go to combine like terms, your eyes can play tricks on you. So I'm going to try to line up my like terms. All right, now I should just be able to go down from there. All right, negative 2x times positive 1 is negative 2x. You're kind of like one line, now you're on line 2. All right, Since I've taken negative 2x and times it with everything in that second function, I'm done with negative 2x. Now I'm going to take the last term and distribute him. So negative 5 times x is negative 5x. So now we're like on line 3, and I'm going to put him under the other just x's. And then negative 5 times positive 1 is negative 5. So now when you go to combine like terms, you kind of just got to add down. They're all lined up for you and ready to go. All right, so the first term is going to be 3x to the third. Then I'm going to have 1x squared. When I add those together, I get 1x squared. Then I'm going to have negative 7x's when I add them together. And then I only have a negative 5 as my just number. And there is your new function that you got from multiplying f and g together. Okay? So again, guys, it's literally, I feel like we're back in chapter 1. Once you get the problem set up, it's right back to just normal algebra skills. All right, the last one, you probably know what I'm going to ask you. Now they're going to ask you to find f divided by g of x. So they want us to take f of x and divide it by g of x. So guys, we are dividing polynomials, if you will. We already saw that when we divide polynomials, it can be a nightmare. It could be a long division problem. It could be a synthetic division problem. But there's another way to divide too. And it's more so a way of kind of like reducing instead of dividing. So guys, watch this. If I asked you to take 15 and divide it by 5, what's the answer to that question? It's 3. Okay. But instead of just doing 15 divided by 5, guys, I could have broken 15 up into 5 times 3, right? Still 15, and divided by 5. But now, PEMDAS says you can multiply or divide. Instead, I'm going to divide my 5s out, and then what's left? A 3. So I still get the same answer. So when we're going to divide these polynomials, we're actually going to set up a fraction, and we're going to look to factor, break it up into pieces that multiply, and then we can just cancel like factors on top and bottom. And that'll be a quicker way to divide it. And it will leave us with a better polynomial. I shouldn't say better, but it's just a quicker way to get to our answer. All right, so here we go. So take f of x, which was 3x squared minus 2x minus 5, and divide it by g of x, which was x plus 1. Okay, so let's see if I can factor the top into 2 factors. Maybe one of them will cancel with the one on bottom. Maybe I'll get another x plus 1 factor. All right, so let's see what this factors to. All right, what times what gets me 3x squared? It's got to be a 3x and an x. All right, the only numbers I can put here have to multiply to that negative 5, and then my rainbows have to add up to that negative 2x. Well, guys, the only numbers that multiply to 5 are 5 and 1, so I don't have any options. That's got to be. It's just where do I want them? Do I want 1 there and 5 here? Do I want 5 there and 1 here? We want the 5 here and the 1 there, because that'll get my rainbows to be a 5x and a 3x. They can make my 2x, so I want a minus and a plus. And then everything will do what I need it to do. And again, I can't stand there and spend a lot of time on the factoring. You should know how to factor. All right, and now it's being divided by x plus 1. So guys, that's a factor of x plus 1. So now, what happens to an x plus 1 on top and an x plus 1 on bottom? They'll cancel, and I'm just left with 3x minus 5 on top. Okay, now let me warn you. When you are dividing the functions, sometimes when you factor, nothing cancels. You don't end up with something that is the same on top or bottom. That just means that this division doesn't simplify at all to a nicer, easier polynomial. So in that case, if nothing canceled, they would allow you to leave your answer in the factored form, or they'd let you leave it in the original division form because it didn't get you anywhere, nothing canceled, okay? All right, so you've seen all 4 operations. All right, let me give you, on the next slide, let me give you the 2 new functions I want you guys to try. So go to the back of your notes. you guys taking the f of x function, which is defined by this expression, and the g of x function, which is defined by that expression. The first thing I want you guys to find, I want you to find f times g of x. So you guys are going to do it there. I'm going to do it up here. Let's see if we get the same answer. You're taking the two functions and you're multiplying them together. What's f of x times g of x? I'm going to give you a little bit of a head start and then I'll start. And again, the nice thing about multiplication is that the order doesn't matter. So if you did f times g or g times f, you wouldn't be marked wrong. It's all going to get you the same answer. Bless you. So that's what we're doing. So you're distributing, a lot of distribution. Watch your signs, watch your multiplying, watch your adding of the exponents. Again, the only trouble about this is, yeah, it's stuff we've done before, but it's so easy to make silly mistakes still. So just try to take your time, don't rush anything, try not to do anything silly. What you got? And you can check your answer with mine. That is my new function when I add f and g together. Oh, no, I'm sorry, when I multiply f and g together. How do you guys feel about that one? Yeah, we got.
Why is Keith the last topic not?
Because I'm a silly goose, Keith.
No,
Good call. Just testing you. I knew that. All right. All right. Sorry about that. All right. And then we go to the next one. Now I want you guys to take g and divide it by f of x. So order matters. Now I've asked you to take the g of x function and divide it by the f of x function. So you're basically going to make your fraction, try to factor, and see if you can get any factors on top and bottom to cancel. All right, I've made my fraction. See if you can factor, and see if you can get any factors to cancel. And just to give you a hint, remember, you are supposed to look for GCFs first. We always look for GCFs. Sometimes it's the only thing you can do to factor something, is take out a GCF. Don't have many options for our factors. We've got to have a 2x and an x. Numbers that I put here have to multiply to 1. Guys, it's only 1 and 1. You can only put a 1 and a 1. Now work the signs to see if you can get the signs to do what you need. You need that negative 1x in the middle. Get your rainbows to get you that negative 1x. And then when you factor the bottom, it doesn't even look right. It doesn't even have the 3 terms that we're used to having. But if you notice, they have a GCF. They have an x in common. And then you're left with a linear factor that won't factor again. So guys, if you notice this time, when you factor the top and the bottom, nothing is the same. Nothing is going to cancel on top and bottom. That just means nothing cancels. So this division, we don't actually have to do it. You could say your final answer is this, that nothing will happen beyond this point. I don't have to actually go through and divide. Or you could put your answer as this, it's just nothing canceled. If you were on Delta Math, it would take either one of these answers because nothing canceled, nothing reduces, so either one is acceptable. So I wanted you to see one where, yeah, you factored, but nothing happened. That's going to happen sometimes. So the good news is they don't ask you to go and then do the long division, or that you're just allowed to leave it as the division problem. All right, I might be able to get you guys to do one more before you go. Now I want you guys to do G minus F of X. Remember, the subtraction, you got to be careful. Subtraction, you have to make sure you subtract all of that second function. And pay attention to the order, because the order matters. Which function are you subtracting from who? A lot of times students just take the first one and then take the second one. Pay attention to the letters. Those are the names of the functions. All right, this is what they're asking you to do. Take the g of x function and subtract the f of x function. But make sure you subtract all of f of x. There's your setup. So you got to distribute your negative, and then you can combine like terms. And that should be your new function. Okay? How do you guys feel about these ones so far? Everybody okay? A red home thumbs up. Are we okay? All right, the last example I was going to ask you guys to do was F plus G. I'd like to think adding's the easiest. I'll put it on the filled in notes so you guys, if you want to look back and check it, but that was going to be the last example. All right, you do have a homework tonight, guys. It's on Delta Math. It is 10 questions on these operations. Just pay attention to the functions that they give you and what operation they're asking you to do. All right, I took the attendance, guys, at home, so you are all good. Have a great day.